Are there any announcements or points that you'd like to make? Does not appear to be. So I guess we'll go right ahead with our presentation today. It's my pleasure to introduce Professor Chris Mead, who is a science education researcher, but like many of us in that field, he came into it from scientific research. In his case, it was isotope geochemistry. Chris got his bachelor's and master's degrees in geology at the University of Illinois, then came here to CC to work with Ariel Anbar and myself, and he earned a PhD in geological sciences in 2014. After that, he did a postdoctoral fellowship in science education at the University of Nebraska with the esteemed Leilani Arthurs, and in 2015 came back to CC as a research specialist in the Center for Education Through Exploration, ETX. But earlier this year, Chris was appointed as an assistant research professor in CC. So he really is Professor Mead now. All excited about that. Chris, as you'll see, studies digital online learning experiences, educational evaluation. A lot of his work contributes directly to diversity, equity, and accessibility in science education and inclusivity. It's worth noting that in 2020, a paper in the Journal of Geoscience Education, for which Chris was the lead author, won the Outstanding Paper Award for the year in the Journal of Geoscience Education. So it's very clear that Chris also has some leadership roles in the geoscience education community already. Very clear that he's a rapidly ascending discipline-based education researcher. And for the benefit of the graduate students who are in the audience and online, I want to point out that this esteemed and rapidly rising career came completely out of Chris's second project. Okay, so mull that one for a moment. It was the second project that led to all of this stuff. So the second project can be very important, and we want to keep that in mind. But today, Chris is going to talk to us about digital and fully online education, pushing forward without leaving people behind. So with that, let's welcome Chris Mead.
I was told this should click on after a couple seconds, so we should be hearing me okay? Fantastic. Thank you, Steve. Thank you very much. It's certainly my pleasure to be giving a colloquium in CC after sitting in a lot of them myself. And I know that we have quite a few local speakers in the colloquium series this semester, but it was certainly my pleasure as a graduate student to learn more about the incredible number of people in this department. So I hope that especially the graduate students and undergrads will benefit from this, even though we don't have an outside presenter this week. So I'd like to start by briefly outlining what I'm going to be talking about. I'm going to spend about 2/3 of the time talking about research and curricular work related to innovative digital learning, with a particular focus on virtual field trips. In this first section, I'm going to be discussing ways that these approaches to digital and online learning can advance equity in education, but that won't be the primary research outcome that I'll be speaking. I think it does contribute to equity, but that will actually be the focus of the second portion of the talk, where I'll describe research directly examining educational equity at the undergraduate level. So as I said in the first part here, I'll be talking about virtual field trips, and I'm going to be sharing results from 3 completed studies that examine learning outcomes from IVFTs, virtual field trips. And then I'm going to spend some time talking about a very exciting project in the works and what educational and research outcomes from that new project that we'll be seeing coming years. All right. So what is a virtual field trip? Some of you have probably already had a chance to look at these yourself, or maybe even use them in your teaching. But what you're looking at here is some video clips from Surviving Extinction. And so what you're seeing is a scientifically grounded illustration of a scene from just before the end Permian mass extinction, about 250 million years ago. Like all of our virtual field trips, I'm clicking and dragging to interact with this scene. I can use these icons throughout the scene to learn more about the animals that lived at this time, the conditions, the environment of that period. And if I weren't in kind of cheating mode here, if I were a normal student, I would have a series of questions that would walk me through understanding the key points of this. Now, I can also use this icon in the center here to visit a modern day site and to see how fossils from this period were preserved and how they're studied by scientists. So again, here I can also pan and adjust my view freely. And as I look down, I can see our site expert in the field Again, if I were in student view, I would have a short video clip where she speaks to her research and the importance of this site. Now you can see I'm looking, she's actually looking at this kind of unusual shape here. You can also access this overlay feature, and this provides a detailed kind of annotation to this. And this is one of the features of virtual field trips. What's really nice is that you can highlight exactly what a scientist really sees this. So even if the student doesn't appreciate that this is an interesting model, we as the learning designers can bring that information. And then finally, this is an example of a gigapixel, which is a freely zoomable, very high-res image that allows you to get all the way down to that rock level. So hopefully that's a good introduction for those of you who haven't used a virtual field trip yourself, for the basic look and feel of these experiences that I'll be talking about in the coming slides. So a little background. Virtual field trips as a concept certainly predate the work at ASU, but Jeffrey Bruce in particular and other contributors within what's now the ETX Center deserve credit for a number of important advancements in how VFTs are developed and used. In our 2019 paper, the one that Steve alluded to already, we defined and explained the rationale for what distinguishes what we call IVFTs, interactive and immersive virtual field trips, as opposed to the broader concept of virtual field trips that's used in a lot of places last probably close to 25 years. In short, there are two critical features. First, because our goal is to provide an active and inquiry-driven experience, it's important to have a meaningful, engaging interactivity. And second, because the goal of IVFTs is to be usable in not only fully online settings, but even large classrooms where the teacher may not have the opportunity to individually support every single student, it's important to have some kind of intelligent tutoring or adaptive feedback to guide students through this experience. So the design approach that I've described draws on several pedagogical and technological strategies with strong evidence of effectiveness. These include active learning, inquiry learning, intelligent tutoring, or adaptive feedback, and place-based education, among other researchers. It's not just us at ASU and ETX that are making and doing research on IVFTs. I'd also like to mention, in particular, Alex Klippel and Jiayan Zhao, his colleague. Both are doing interesting and notable work in IVFTs, not only desktop IVFTs, which is what we specialize in here, but also VFTs that use virtual reality. So next, I'm going to summarize some of the evidence of effectiveness of these IVFTs. And here, the research is going to be using content assessments, a pre and post test design, and this is either with or without a comparison population. Of course, where possible, having a comparison group that uses a different mode of learning is a stronger design, and that's where we're trying to move forward to, and that's the design that you'll see in the future work that I'll describe. And before I go into the results, I want to quickly acknowledge the key contributors for this section, who include Jeffrey Bruce and Wendy Taylor of the ETX Center, or Steve, seen before, Nari Landbar, professors in the department, Tom Roberto, a current graduate student, and Sandra Buxner at the University of Arizona, a key contributor of computers. So in the first study, the one published in JGE in 2019, we examined and presented learning outcomes from the virtual field trip examining the Neopina fossil bed in South Australia. So in this study, we examined learning outcomes from high school students and undergraduate students, both using the same virtual field trip. Students completed a built-in 6-question content assessment, both before and after the lesson. And for the high school students, we were able to, again, measure their learning 10 weeks later, a retention. So as you can see from this, in the orange bar, the immediate post-test was very strong and virtually the maximum possible scale. But even that 10-week delayed assessment in blue is still more than 2 points greater than their pre-test score. So for an hour-long educational experience, having that level of retention 10 weeks later is quite impressive. In the undergraduate population, we did have more students to work with. We see a similarly large immediate gain in the post-test. We weren't able to measure the retention later, but again, this kind of does confirm what we're finding in the high school population. A second example in this section examines surviving extinction. This is the same VFT that I showed you a video clip of a minute ago. So surviving extinction is a sophisticated and highly detailed IVFT through which students learn about the history of vertebrate evolution over the last 350 years. Surviving extinction also makes significant innovations beyond prior IVFTs, by our group even, including extensive use of gamified design. So this includes collectible elements at hidden locations to motivate deeper engagement by students. It also blends simulated environments with real captured media from modern day sites. And this maintains both a unified visual look and feel, and it helps students to connect the modern fossils to their likely ancient environments. As with the Nilpena study, we again studied surviving extinction using a pre and post design, and in both a high school and an undergraduate classroom. And this study was published earlier this year in Frontiers in Education. So moving to the results, we, again, using a pre and post-test design, you can see the high school data is on the left-hand panel, undergraduate data right-hand. Overall, 80% of students improved their scores pre to post-test. These are indicated with the filled circles. Having the two different populations, in this case, allowed us to test and examine the effectiveness of this learning experience for students with very different prior knowledge. So if you look at the horizontal axis, the pre-score, you can see that the high school students are clustered with a mean of about 5, whereas the undergraduate students have a mean of about 10. Yet in both of these populations, they showed significant, substantial learning gains pre-post. So this suggests that not only is this an effective learning experience in general, but it's even effective on quite a broad range of prior knowledge. And the third completed study that I want to describe in this section is Tom Roberto's master's project here in CC. And the goal of this project was to compare learning outcomes between an in-person Grand Canyon field trip and the Grand Canyon IVFT. So shown here is the Mystery of Blacktail Canyon virtual field trip. So we're actually deep in a side canyon where we have a very close-up view of the Great Unconformity. Now, in contrast to the previous two studies, where we had a combination of multiple choice and short answer assessments, here the outcome measure is a concept sketch of the Great Unconformity. Now, concept sketches are an excellent technique for both learning and for assessment, particularly in geology, because of how they blend conceptual understanding with visual representation. So this is a really robust outcome measure. And in addition to that, as I said, we did have the opportunity to have a comparison population in this study. So this was conducted in 2 undergraduate courses, one at the 100 level, shown in the top row, and one at the 300. And in both cases, students chose to attend either the in-person field trip or the virtual field trip. So now this did not employ random assignment of these conditions, but it is still an opportunity to compare 2 different modalities of learning. So if we look at the individual pre and post trip scores, we can clearly see a sharper increase from pre to post in the virtual field trip condition on the right. And we see this same general pattern in both the 100 level and the 300 level courses. And a linear regression model result confirms what we can see by eye, with the virtual field trip condition being associated with an increase in post-test scores of about 1.4 points relative to the comparison. We also find this effect to be consistent between the 2 courses. In other words, the course was a non-significant predictor in the regression. So this is an interesting result, and I think it speaks to 3 important outcomes, lessons. First, again, with the prior 2 studies, it underscores the educational effectiveness of virtual field trips. Second, it reinforces what's known from prior work about the effects of so-called novelty space. That is to say, the almost unavoidable challenges, or the inherent challenges, I should say, that come with learning into distractions of the novel environment and what have you. And third, and I think most importantly, it reminds us that in-person field instruction follows the same rules as in-person classroom instruction. From what we know about active learning, where possible, much more effective to employ active learning techniques than to employ passive learning like a lecture, even if that lecture is being delivered at the rim of the Great Canyon. And finally, in this section, I'd like to talk about a new IVFT project that illustrates the continued evolution, how this medium can be used to enhance traditional instruction, and how it can be used, how it can be studied through education research. And now, because this is a new project, I don't have findings to share yet, but I will share some initial media to describe the planned curriculum. So the polar regions are critically important to studying and to understanding climate change. These areas are also experiencing the most rapid warming of any place on Earth. For students who live outside of the Arctic, it can be really difficult to imagine what life there is like, let alone to appreciate the rapid scale of changes it impacts. Therefore, the goals of the Polar Explorer project are to create a series of connected IVFTs that allow undergraduate non-science students to learn about permafrost, to learn about the challenges of building and living on top of permafrost, about the carbon cycle in permafrost ecosystems, and about why all of this matters for climate change for them living in Arizona, California, and so I was very happy to spend 10 days at the beginning of September in interior Alaska. You can see some of the amazing footage behind me. Our goals of this trip were threefold. One, to collect media for the IVFTs. Two, to build and strengthen relationships with our collaborators in Alaska. And three, for myself and for the other non-polar scientists on the project, to learn about permafrost and boreal ecology. I definitely know a lot more than I did at the end of August. This is a collaborative NSF IUs project. We're starting the second year of 5, and we'll have at least one more trip to Alaska to visit the North Slope. The North Slope will have an opportunity to see some of the very large permafrost structures when they're not disturbed by all these trees. And next, I'd like to talk about the key learning design approaches, and then I'll summarize the planned topics of Polar Explorer. So, although the drone footage that you saw before is beautiful, it's not actually the main way that students will interact with the IVFT. Just like I showed you in Surviving Extinction, the interaction takes place through 360-degree spherical images and interactions with overlay elements, as I'm showing here. This screen capture highlights interactions from an IVFT called Dino Doom, but it highlights an approach that we're going to be using extensively in Polar Explorer, which is data collection and analysis. Students will employ a number of real scientific methods throughout Polar Explorer, including, for example, measuring the depth of permafrost, measuring the temperature of permafrost, tracking that over time using historical data, drilling and analyzing permafrost cores, measuring soil carbon, and examining ecosystem level carbon and energy balance using flux tower data. Answering questions about the world through careful observation and measurement is at the core of science, but it's generally quite challenging to give students a sense of what that means, particularly at an intro-level class. And building on our previous IVFT projects, we intend to make extensive use of these techniques throughout the IVFT. And we see that as being key to not only the research, but the educational outcomes for Explorer. Separately, learning from previous IVFTs, we're also going to work to strike a balance between giving students room to explore and keeping them on track towards their ultimate goal in each IVFT. So then the use of multiple pathways and adaptive feedback has both a motivational and an engagement-related purpose, and also one of being accessible to learners from different prior knowledge. Just as we saw in Surviving Extinction, we're hoping that Polar Explorer will be equally effective across the range from advanced high school, intro non-science major, and even some science majors. Although much of the instruction will be done using real media from the field, some processes in permafrost landscapes are particularly challenging to visualize. We have an expert scientific illustrator, this Victor Leshik, on the team, and he's going to help us to create not only static illustrations like the one you see here, but also animations that rely on these elements to convey some of the more complicated three-dimensional and temporal processes that are important in permafrost studies. Last, although certainly not least, we will leverage to we will work to leverage place throughout Polar Explorer. Our goal there is to help students to begin to form some kind of an emotional connection to Alaska. We'll do that both through featuring visual media, the grand visuals as I've shown some already, and also by featuring videos of Alaska natives and those with long personal or professional connections to Alaska, describing why that area is so important. The one project we're particularly excited to work with is the Alaska Voices project. And they've taken an NPR StoryCorps approach to the videos that they collect and have a number of brilliant examples showing these human experiences. Because the practice of science will be at the forefront of Polar Explorer, students will spend a lot of time getting to know scientists and their work, looming over me. But to the left, we can see the lead subject matter experts on the project. Michelle Mack, ecosystem ecologist, Debbie Hunsiger, climate scientist, and Kevin Schaefer, studies permafrost hammocks. These are the co-PIs in the project, and Debbie's the overall lead. But although Kevin, Michelle, and Debbie will be the primary voices, they won't be the only ones that students hear from. On the trip, we were also able to capture footage and learn about relevant scientific research and techniques from a number of other scientists. And just briefly, we have Vladimir Romanovsky and Eugenie Uskirkin, both professors at Alaska Fairbanks, Jillian Frost and Jamie Hollingsworth, who are field managers at the Nancy Creek LTER, and Justin Ledman and Zev Axler, who are field technicians for a Northern Arizona university. So the actual structure, very briefly, of Polar Explorer starts from the big picture and explains what kind of all the things that the student needs to learn about and hopefully will want to learn about. Then going into the question of what is permafrost, how does it form, and what effects does it have on the landscape. See, Kevin here is inside the permafrost tunnel, gesturing to a large preserved ice wedge. And here is an example of a permafrost core, where you can see two visible ice layers. So this permafrost core is one of the many techniques that we're hoping students will engage with directly and draw inferences from their characterization of these cores, and even make quantitative predictions about, for example, subsidence as a result of ice melt. Next, students will learn about the many, many risks to infrastructure built on top of permafrost. So at the center, you can see an example of a ruined boardwalk. This is basically right in the center of Fairbanks. And at the right, a tilted telephone pole. This is caused by a process called frost jacking. It's an extremely common example of infrastructure damage as a result of permafrost thaw. And the second half of Polar Explorer will ask students to build on the connections from local carbon cycles in various Arctic ecosystems to the global carbon cycle and climate change. So shown here are some images of retreating ice, which is probably the first thing people think about as a consequence of climate change. But there are also many more subtle ways in the Arctic that consequences of warming are. So across interior Alaska, there exists a continuum from warmer to cooler ecosystems. And each of these have their own characteristic carbon flows, carbon pools, and students will use soil observations, soil carbon data, and eventually data from flux towers, like the one shown in the center here, to understand these ecosystems. And from that understanding of these disparate local ecosystems, they'll draw conclusions about the overall effect of warming Arctic on the global carbon cycle and climate change. So, as I've shown through the results from previous studies, and as other researchers have found, virtual field trips are, when well designed, well implemented, an effective instructional tool for the kinds of content-focused learning goals that are expected from lecture classes. However, I think it remains to be demonstrated exactly how well IPFTs teach the kinds of skills that lab classes are supposed to teach. Given Polar Explorer's focus on field methods and learning through observations and data, measuring learning gains related to the choice of methods, data interpretation, and understanding of scientific practices will be points of emphasis in the research that we will conduct on finished Polar Explorer project. We will have opportunities to study Polar Explorer in an existing climate change class at NAU, as well as a geologic hazards course. So this will hopefully give us an opportunity to employ that comparison group design that I described. I certainly predict that Polar Explorer will have a substantially stronger learning experience in these areas than would be present in typical instruction. And I look forward to sharing those results in a couple of years, finish building it, had a chance to conduct that research. It's a long project. So in the remaining time, I'm going to talk about research that's been funded through the Howard Hughes Medical Institute's Inclusive Excellence Program. And this was a grant awarded to Jim Collins and Solz. So interest in diversity and differential success of students in science is hardly new. For example, questions have been raised about the lack of diversity since at least the 1970s. Those of you who participated in the URGE pod last year may recall this very study from 1972. There is also the often criticized leaky pipeline metaphor for low gender and other diversity among STEM professionals and STEM faculty, and that's been in use since at least the 1980s. But there's increasingly a shift away from the focus on individual factors or even overt or intentional factors of any kind towards an examination of systemic and structural factors that are supposed to have led to the continued inequitable success of women, Black, Hispanic, and Indigenous students and others in STEM. A recent commentary by David Asai is one example of the shift in framing. And there was also a very recent article co-authored by Sarah Brennell from ASU, describing the concept of infrastructuring as a means of drawing attention to these otherwise hidden structural factors in higher education. So this structural approach is the one that I and my colleagues have taken in the work that I'm going to describe next. So one more piece of prior work, a 2017 paper by Becky Matz and colleagues provided some important motivation for our work. So this study examined over 1 million STEM course enrollments from 5 institutions, and they found a consistent pattern in which lecture-style courses, the gray circles in this diagram, are typically harder, meaning that students earn lower grades in those courses than they do in their other coursework, and that they show a common gender gap in which men earn higher grades than women, even after accounting for differences in student GPA. Although this study didn't compile or analyze the instruction or assessment strategies in these particular courses, the result is consistent with what's known from prior research showing disparate grades for example, women on high-stakes exams, or on the other hand, more equitable performance in smaller classes, the classes that emphasize collaborative. So seeing that result, we had a range of follow-up research questions of interest. For us at ASU, one obvious question is, do these same differences exist in the online population? And while the Matz paper focused on gender, it was also natural to ask the same questions relative to race or ethnicity, first-generation college status, or income status. Further still, there are questions of intersectionality. That is to say, the idea that multiple social identities intersect lead to distinct experiences. And although much of the work I'll show is aggregated across many years of enrollment in different courses, there are also likely interesting lessons to be learned at the level of specific courses or specific course sections. So the work I'm going to talk about relies on institutional data with both academic and demographic information. The first study I'll present uses what's called a mixed effects regression to estimate the effects associated with demographic categories. The mixed effects means that it includes not only the fixed effects, which you think of as typical linear regression, but also random effects, which account for the fact that individual students may be represented multiple times in the data, and they may be nested in particular course sections. The second study I'll talk about takes a similar approach, and the third uses a technique called quantile regression, which allowed us to draw robust conclusions even at the course section level. And although not included in the studies that I'm going to highlight here, I do want to mention that some of our other work does use instructor and student surveys. And these are really a valuable way to contextualize the otherwise rather dry administration. So in the first study, I was collaborating with, again, aforementioned Jim Collins in Seoul, as well as Sarah Brunel, Ariel, and Dean Paula Poor, college, and Supriya, who was at the time a postdoc and is now at UCLA. The first study I'll describe is what we called our baseline analysis. This was published a couple of years ago in PLOS One. Now here we were really directly motivated by the MAT study, and we were interested in extending that demographic analysis beyond gender, as well as to see whether these grade inequities were at all different on the program. This work relied on over 10,000 student course enrollments from 5 academic years. And this was all using the online and in-person biology program results. So what did we find? First, looking at only average grades by program type, we see the online program students earn grades roughly half a letter lower than the in-person students. Now, that's obviously a big difference on its face, but on top of that, our analysis shows that this program attracts more women, more first generation, more low income students. So it's doubly concerning if the program itself is leading to worse outcomes. Now, one caveat I would like to make on this slide is that there is a selection effect. And by that, I mean the online program and the in-person program don't historically draw from the same pools of potential students. And moreover, from an analytical perspective, because there's no cross-program enrollments, we are somewhat limited in our ability to precisely estimate this difference. Nonetheless, I think a large effect is quite likely. Now let's look at the demographics. So there are two things that I'd like to highlight in these results. First, we see significant, if somewhat small, grade gaps favoring the historically privileged groups highlighted in blue. And in particular, the grade difference for gender is very similar to what the previous MAT study. The second finding is that for 3 of these 4 categories, everything except for first generation status, the grade inequity is statistically equivalent in the in-person and online programs. Now, while the presence of these differences in person is not a completely novel finding, grade differences related to, in STEM related to gender, race, ethnicity, or socioeconomic status have been published before. What is novel is the consideration of the parallel online program and the finding of no difference between those programs by this measure. So the similarity in in-person and online, it reinforces our incoming assumption that the grade differences themselves are primarily driven by structural causes, such as, for example, systemic racism, implicit bias, income-based school funding, or gendered roles in peer-to-peer interactions. Now, on perhaps a more positive note, we could extend this result to conclude that when efforts are made to ameliorate these differences, they will probably provide comparable results, benefits in both the in-person and the online program. We argue that they have similar causes. The next 2 studies were both done as part of called the Seismic Collaboration. So this is funded by the Sloan Foundation and was led and originally conceived of by Tim McKay, a physics professor at Michigan with a strong interest in undergraduate education. So what the Seismic project is about is bringing together 10 different similar large research universities, including ASU, and giving the researchers at those schools an opportunity to conduct parallel analysis. So in simple terms, researchers like myself analyze the data from our universities and aggregate those results to a pooled study across the universities. So this allows us to avoid the complicated data sharing challenges, but still have the power to make these comparisons and to magnify the impact of projects. So although there are too many people to call it by name across Seismic, I will mention Sarah Castle at Michigan State and Cameron Zanero at UC Irvine, who led the 2 studies that I'll describe. So the central question of the first of these studies is very similar to the prior work that I described at ASU, but with the added goal of examining whether grade inequity is similar across the 7 schools that participated in this project. The plot I'm about to show compares the average grade anomaly for students with a number of different systemic advantages that any one student has. Now, let me explain these two pieces of jargon. Grade anomaly is simply the difference between a student's grade in a specific STEM course and their GPA in all other courses. Since large introductory STEM courses tend to be harder than the average course, you'll be seeing negative values. Now, a systemic advantage, on the other hand, this is simply a reframing of the same demographic categories that I analyzed previously. So, for example, a white female student who is not first generation nor low income would be considered to have 3 systemic advantages by this measure. As a second example, a Hispanic female student who is first generation but not low income would be considered to have 1 systemic. So now, while this approach is somewhat coarse, and while it doesn't fully embrace the ideas of intersectionality, because we are still lumping disparate combinations of demographic groups together, I think it is a useful first step towards asking if and how being a member of multiple marginalized populations impacts a student's likelihood of success in this course. So to the results. There are a few things I'd like to draw your attention to, which are, first, overall, we see that multiple systemic advantages confer an additive benefit in course grade. Although moving between 3 and 4 advantages does seem to have a different effect at some of the institutions. And second, we find that grade benefit associated with systemic advantage, which is to say the slopes within each institution's plots, are quite similar across the 7 institutions. So the differences actually largely lie in the y-intercepts of these different trend lines, which is something that reflects the average difficulty of STEM courses at that institution relative to other courses. So to the question of grade equity, we again find considerable similarity among these different schools. In the previous results I've shown, we see evidence that STEM course grades are systematically lower on average for women, students from historically marginalized racial and ethnic groups, first-generation students, and lower income students. In contrast to the student-level focus of the prior results, in this final study, our unit of analysis is actually the course section. So we had 2 main goals in taking this approach. First, we wanted to look more closely at the distribution and the magnitude of grade inequity at different universities. Again, kind of an enhancement of the goals of the previous study. And second, looking towards solutions to the problems. We're interested in taking a close look at instructors who have consistently equitable grading. So although the literature has pointed to teaching practices that are more equitable, it may still be illuminating to pull examples from practice in hopes that these are more generalizable or repeatable. So first, I'm going to show you results by gender, just to get you acquainted to the plot. So this histogram shows us results from about 3,000 class sections across the 5 universities that participated in this study. The horizontal position shows the difference in course grade, in this case between male and female students, with negative values indicating lower grades for women. And the specific metric used here comes out of that quantile regression technique, which I described before. So this allows us to adjust for students' prior academic performance, but without relying on the assumption of normally distributed data. In this case, we see that in aggregate, once again, there is a negative bias for female students in most of the classes. So overall, about 70% of the specific course sections studied had a negative gender gap. And this is also an opportunity for me to mention that although the approach we've taken throughout does rely on binary comparisons, there's a particular blind spot in the administrative data that I rely on to non-binary gender. Federal reporting, for example, the IPED system, requires ASU and other universities to collect legal sex. That's the category. So although student applications now allow them to indicate their gender identity and their preferred pronouns, it is for the time being quite difficult to do these studies in a truly inclusive manner of gender diversity. So taking the gender plot that I showed on the previous slide and filling it out to show the other categories of comparison, you can see again that these are slightly more unequal than we see for the gender comparison, with the mean differences ranging from quarter of a letter grade to more than a third of a letter grade for waist thickness. And on a per section basis, more than 80% of class sections have negative grade differences for Black, Hispanic, Indigenous students, and for first generation students. And about 75% of sections have a negative grade difference for low income. But having said that, I will conclude by pointing to the roughly 20% of course sections that fall on the right-hand side, the positive axis, positive x-axis. A number of seismic schools, including ASU, are preparing a proposal to look more carefully at these potential bright spots. So I can't speak yet to how the data will shake out at large scale, but I can say from looking at specific courses here at ASU that individual instructors are not randomly distributed these trends. And so I'm optimistic we can start from the administrative data, use them to identify specific courses, instructors that consistently award equitable grades, and then take a case study approach to examine the specific practices used in those classes and by those instructors. And in that way, we can supplement the body of literature that speaks to equitable teaching in theory with some detailed information about equitable teaching practice. So as a conclusion, let me return briefly to the first topic, digital and online learning. So I hope I made a good case for the capacity of resources like the IBFT or the Habitable Worlds course that I sadly did not have time to talk about to meaningfully enhance learning, whether in person or in fully online settings. And speaking to a scientific audience here, I'm perhaps most enthusiastic about the potential modeling scientific thinking and scientific practices, particularly for non-science majors who have very few opportunities to practice these skills. But how does this contribute to educational equity? My hope is in a combination of ways. Research shows that active learning and other student-centered teaching has a disproportionate benefit for minority students. These technologies are also amenable to showing the applications of science in real-world settings, which is something that can be of greater interest to low-income or first-generation to college students. And because these resources extend what any one teacher can do on their own, there's also the possibility that by presenting more diverse voices in instruction, we could engage more and more diverse students. Now, I certainly don't believe that these tools are a panacea for the problems we see, but I do certainly see them as part of the solution and undeniably part of the solution to the goal of providing high-quality education to students. So I hope from that I'm pretty much right on time, and I'd like to briefly acknowledge the funding for the different projects, which includes a number of NSF grants, support from NASA, support from the Howard Hughes Medical Institute's Inclusive Excellence Program, and support and collaboration from Seismic. With that, I'd love to take any questions we have. I guess we'll start with students.
Can start with some questions from students. Right in the back there, we have any questions? Yes. Okay, yeah, we have, because of Zoom.
Oh, right.
Hi, Professor Mead. I absolutely loved your presentation. I am a big fan of the virtual field trips. I've gone through Surviving Extinction, and I've messed around with building my own as well. But I do have a question for you about diversity. The whole goal with these VFTs I see is to reach as many students as possible and educate them. Are the VFTs that like ETX has, are they offered in various languages?
That is a good question. We actually, I'm gonna cheat by putting the best possible example of this out and mention collaboration that I have not been involved in person, but ETX Center has done a lot of work with the Kamehameha schools in Hawaii, and so they worked with us to develop a multiple VFTs that were bilingual, including Hawaiian language and English. So now that's sort of a special case because they were really driving that one. I know that we have with the Small Worlds lesson, for example, developed a version of that in Spanish. And in principle, there's certainly no reason why they couldn't be extended to be multilingual. It is just text after all, so it would be a matter of effort. Really. There's nothing fundamental stopping.
So it's something that you foresee happening in the future with some of these.
I think that, like so many things, it's kind of a matter of having the funding and motivation to do it. If there's an interested person who is bilingual and had a passion in kind of extending one of those things, then I think that's, for example, a student project, I should say, and I don't see why there's a reason technically that we couldn't do that.
Yeah, the question in the row next back there.
Hi, I wanted to ask if there was a difference in the grade distributions for disadvantaged versus advantaged students by discipline, like physics versus geology.
Yeah, so that's a good question, and actually, I had to cut some of that for time. Through Seismic, I have not had an opportunity to look very much at geology. I know Steve is grimacing because geology is always excluded from these multidisciplinary comparisons. But the reason is it's just smaller discipline and there's fewer students in it. So I can't speak to geology specifically, but we did have an opportunity to look at differences between biology, chemistry, physics, and math. And at least in some cases, math was somewhat more equitable by those than sciences, although it does differ between the four different comparisons. So we did have an opportunity to look at it.
So those were the courses in the seismic study, those disciplines?
Those are the main, yeah. So the main courses have been math, biology, chemistry, physics, although each one of the projects differs slightly.
Did you control for level of quantitative work in the courses?
We do, when we make those comparisons, try to not mix calculus physics versus non-calculus physics, for example. And for example, I'll be honest, it's actually very challenging when we get into it to do multi-institution studies because everybody has their different way of doing things. But in general, we've tried to operationalize for the goal that the course serves in the curriculum. So for example, if there's a chemistry course and it's for non-science majors, that's a really different chemistry course that's for chemists or biologists or engineers. So that's usually the way we parse that.
Next row back.
Hi, so I guess I had a question about kind of like who your audience is for this, because it seems like it's like large intro classes, but it seems also like the time it takes to make one of these is probably a long time.
The virtual field trips.
Yes, and just like to put together a course, like how long would that take?
Yeah, that's a good question. So the audience for the virtual field trips in general has tried to be rather inclusive. We trying to think of an exception, but in general, we try to shoot for intro non-science major as the main audience, with the idea that that's probably going to be fine in a lot of ways for an intro science major audience. So, for example, the surviving extinction lesson was tested in SES 123. So that kind of intro science, but also to that high school population. Again, by and large, we feel comfortable including advanced high school students with lower level intro undergraduate students.
Just one more follow-up one. So for like during the pandemic, a lot of courses moved online and a lot of people were scrambling to actually like make a course. Do you have any resources like that, like you do? I know this is like way more advanced than what a lot of the courses online look like now. Or is this kind of just like a very separate, trying to target a new population of people?
I'm sorry, could you rephrase that? Resources for what exactly?
Resources for like making engaging online content for a course, because it seems like a lot of this is like very professionally done, and there's kind of like a dichotomy, I guess, with then like what a lot of online courses are being made into now. And obviously this looks way more fun, but it doesn't seem feasible on a shorter time scale.
Yes, so the ETX Center has I think two different projects in the works that try to serve that need in different ways. One of them, so with the new adaptive learning environment that the course, for example, HabWorld teaches, there's a version of that that's in development that's intended to be more user-friendly for new teachers who want to come in and use some of the adaptive platform features in designing their classes. Now, that's still even if that's user-friendly, it's still going to be that's a substantial like effort for an individual instructor to make a fully adaptive course. That would be a much bigger lift. But what I'll also mention is the Tour It project. The Tour It is a way to make a more user-friendly and more approachable version of virtual field trip design. So essentially, it's a way to capture a series of 360-degree images, which you can do with your phone or one of these nifty Ricoh Theta cameras. You can drag and drop those into a web interface. You can add some hotspots, some interactive elements. I am frankly an enormous fan of it, and I think it's maybe actually a better answer to the question. So if you did have access to a site you wanted to show your students, you can go out there with your phone, take 20 minutes, capture some media, and share that back to them, even if they are in their apartment, in their house. So I think that's actually maybe the better answer.
Yeah, so Anna Sophia says, have you done any work including diversity, such as recently physically disabled students in a traditionally physically demanding major like geology?
No, I have not. I have not done. I can point to Chris Atchison's work and his collaborators as somebody who is in the geoscience education space and does a lot of work about physical accessibility in physical field trips. I have been working on a project that is on students with disabilities program, but that's not really quite on point.
The next one is very, very similar. Do these virtual learning resources have accommodations so that to allow for students with disabilities to succeed?
Yes, with a but. So we certainly do try to make them as accessible as possible, including captioning for videos. But I hope I'm not speaking out of turn. If Jeffrey may answer this differently, but I think the answer is that to make it completely accessible for somebody who cannot see, for example, would require, it would require a full narration of what's happening, what are the interactive, like you have these descriptive captions, like the best practices for captioning a resource to make it accessible. You can't just say what's there. You have to think about, well, what's the point of this learning? Like, what's the point of this in class? What does the student have to learn from it? And then you have to write a caption that gives that visually impaired student the ability to get that same lesson without being able to see it. So like that level of accessibility for the virtual field trips is a challenge.
Okay. First of all, I want to thank you for bringing attention to the
Oh, sorry.
lack of information there is for gender nonconforming students as it relates to our experiences with difficulties within the similar gender vein as you mentioned. But I did want to ask, you mentioned that there hasn't been a significant amount of study or determination done as to the effect of virtual field trips and similar systems as they relate to laboratory skills. I was wondering if you personally would have any thoughts as to how effective you think they will be in the future as they potentially become developed for teaching laboratory skills in various scientific disciplines.
Yeah. So I'll say just offhand that I was kind of being a little narrow in saying that within the virtual field trip space, certainly there's work in kind of virtual labs in that space. There are things there, but as far as my thoughts on virtual field trips in filling that role, I think it's probably obvious, very optimistic that these are going to be a great resource. I think the design we're taking and the kind of amount of realistic, if simplified, scientific data that we're planning to put in some for Explorer, I think it's going to be a dramatically better scientific thinking learning experience for these kinds of non-science majors than they would ever reasonably get. Even if there is a lab, again, labs are often rather cookbook, they say. And, that's a limitation of working in a lab. When you have the power of digital, you can really go a lot of places that would be completely impractical.
Okay. Just one more quick follow-up to that. Did your data or whatever research has been done show any significant difference between the usage of virtual and augmented reality systems versus just simple display systems for the effectiveness of virtual field trips?
So I have not looked at that, but there is one of Alex Krippel's studies did try to, they had a three-way comparison between an actual field trip, a desktop-based field trip, and fully virtual reality. And in general, they didn't find notable differences between learning outcomes of the full VR and the desktop experience. So I have thoughts on that space, but to the extent that there's been research published, I think that's the only.
Okay, thank you.
Question online?
One more online. This is Daryl Reno, and it's a
Hi, Daryl.
short one, so I'll try to be brief. Do the theoretical frameworks you are using include components with critical theory?
Yes.
Many times, equity-driven research is problem-based or arises because researchers' personalities. What are the driving motivations behind the various research collaborations to pursue this important research beyond the standard to make the discipline a better place?
Yeah. So I'm going to try to answer this one very honestly. Through my collaboration with other members of the Seismic, I am very happy to say that I'm becoming more well-grounded, informed about critical theory and its informing of this kind of. And so I think certainly people I work with absolutely see that as being directly informed of that. And I am, as I hope I made clear in my presentation, I am informed in that, although I think, I should say, I'm motivated by the ideas of critical theory, that even if I don't yet consider myself a completely qualified expert to speak on it at greater level. So I hope that answers the question, Gerald, from Pastor.
Thanks, Daryl.
Hi, so regarding the virtual field trips, what effect did they have on students' self-efficacy levels?
To be honest, that at least in work that I conducted, I have not measured that. That is something that will be included in the plans for Polar Explorer. We are interested in investigating how that lengthy experience does change students' affective, it changes students' affective outcome, including perhaps self-efficacy, but I think we're interested in sense of belonging and science.
Thank you.
We have time for one more question. Right there.
Hi, thank you so much. I was just gonna say that you mentioned the Alaska Voices. You mentioned Alaska Voices, who, from my understanding, you collaborated with for the Alaska VFTs. So I was wondering, how can we ensure respect for and build better relationships with the indigenous communities whose lands are often being studied and probably included in a lot of these VFTs?
Yeah. So our collaboration with Alaska Voices is nascent. We did meet the Jamie, the director of it, when we were in Fairbanks, and had a really amazing conversation. And we are very, very actively exploring ways to find meaningful collaboration with people who can help us. Because as you probably could see from the guys with us in Alaska, that is not the representation that we have at the moment, but we are aware of that. So Jamie, Jesse in particular, does have good connections. We are also hoping to form collaborations with some people at Alaska Fairbanks who are themselves students. But at the moment, that is a goal. We really do want to find a way to to include an authentic presentation in their own words of Alaska Natives and how their communities are and will be impacted by warming. I can't say exactly what that's going to look like because I haven't nailed down who that collaborator is going to be.
Thank you so much.
Thanks for the question.
We'll take one more online.
Actually, there's these are just comments, follow-ups. One is from Jeffrey Bruce, and he says the ETX software turret has been developed with complete ADA options for authoring, developer, user, as well as complete ADA compliance with what is produced output from authoring platforms. So he wanted to comment on that. And then Jack Palmer says the 3D image files of specimens for online access currently is limited to Sketchfab, and are there any ASU available 3D storage?
Not my department.
Okay.
All right, let's thank Chris again. Thanks, everybody. We'll see you next week.
Okay.